Idle mode procedures. Let's get into the topic. PLMN selection. The UE is responsible for selecting a public LAN mobile network for subsequent cell selection. A PLMN is identified by its PLMN identity broadcast within System Information Block 1, that is SIB1. A single cell can belong to multiple PLMN, so SIB1 may broadcast a list of PLMN identity. The UE non-access stratum layer can request the UE access stratum AS layer to report available PLMN. The UE scans all RF channels within its supported frequency bands. Second, the UE searches for the strongest cell on each carrier and reads the system information to identify the PLMN. Third, PLMN are reported to the NAS as high quality if their RSRP is greater than or equal to -110 dBm. In this case, the measured RSRP value is not reported to the NAS layer, so high quality PLMN are not differentiated by their signal strengths. Fourth, PLMN which do not satisfy the high quality criteria are reported to the NAS together with their RSRP measurement. Fifth, UE can optimize the PLMN search procedure using stored information, for example, carrier frequencies and cell parameters. Sixth, the NAS layer can stop the search at any time, for example, after finding the home PLMN. The NAS layer is responsible for selecting a PLMN from the list of reported PLMN. The NAS layer uses information from the USIM to help with PLMN selection. First, International Mobile Subscriber Identity (IMSI) defines the home PLMN, that is HPLMN. Second, HPLMN selector with access technology defines the priority of each technology associated with the HPLMN. Third, user controlled PLMN selector with access technology allows the end user to prioritize the PLMN and technology. Fourth, operator controlled PLMN selector with access technology allows the operator to prioritize the PLMN and access technology. Fifth, forbidden PLMNs defines PLMN which the UE does not automatically attempt to access. PLMN are added to the list of forbidden PLMN when the network rejects a registration request using a cause value, PLMN not allowed, or serving network not authorized. Sixth, equivalent HPLMN, that is EHPLMN, defines a set of PLMN which are treated as equivalent to the PLMN the UE is registering. This list can be updated or deleted by the network during the registration procedure. The PLMN can be selected either automatically or manually. In the case of automatic selection, the UE selects the PLMN and access technology using the following order of priority. First, HPLMN. If EHPLMN list is not available, or the highest priority EHPLMN if EHPLMN list is available. Second, PLMN and access technology combinations defined within the user-controlled PLMN selector. Third, PLMN and access technology combinations defined within the operator controller PLMN selector. Fourth, other PLMN reported as high-quality PLMN selected in random order. Fifth, other PLMN selected in order of decreasing signal quality. The UE searches all supported access technologies before selecting a PLMN when using Step 4 and Step 5. In case of manual selection, the UE presents the end user with the available PLMN listing them in following order. First, HPLMN or equivalent HPLMN, that is EHPLMN. Second, PLMN and access technology combinations defined within the user-controlled PLMN selector. Third, PLMN and access technology combination defined within the operator-controlled PLMN selector. Fourth, other PLMN reported as a high-quality PLMN selected in random order. Fifth, other PLMN selected in order of decreasing signal quality. The end user is then able to select which PLMN the UE should attempt to access. Let's get into the topic. Cell selection is used to identify a cell for the UE to camp on. It is applicable after a UE is switched on, after a UE leaves RRC connected mode, and after a UE returns to an area of coverage. Initial cell selection does not rely upon any stored information. The UE scans all the RF channels within its supported frequency bands. Scanning is based upon the synchronization raster. This raster is relatively coarse to reduce the number of candidate carrier frequencies and thus reduce the delay generated by band scanning. The UE searches for one or more SS or PBCH blocks at each candidate carrier frequency. Each candidate carrier frequency has a global synchronization channel number GSCN. After finding one or more SS or PBCH blocks at a specific GSCN, the UE identifies the strongest cell and proceeds to decode the system information. It is possible that the UE discovers a set of SS or PBCH blocks which do not have any associated system information. In that case, the PBCH can provide information which directs the UE towards another set of SS or PBCH blocks. A UE is permitted to use stored information to support the cell selection procedure. This can include carrier frequency which the UE has previously camped on. It can also include cell parameters from previously received measurement control information or previously detected cells. In the case of cell selection after leaving RRC connected mode, the base station can use the RRC release message to direct the UE towards a specific carrier. A UE uses the initial cell selection procedure if cell selection based upon stored information is unsuccessful. A UE attempts to camp on a suitable cell during the cell selection procedure. If the UE fails to camp on a suitable cell, then the UE will attempt to camp on an acceptable level. When camped on a suitable cell, the UE can register with the network and access its normal set of services. When camped on an acceptable cell, the UE is restricted to limited services, that is, emergency calls and reception of public warning system (PWS) notifications. A suitable cell is defined as a cell which is not barred. Second, belongs to the PLMN selected by the NAS layer, the registered PLMN or an equivalent PLMN. Third, belongs to at least one tracking area which is not forbidden. Fourth, satisfies the cell selection criteria. The master information block MIB uses cell or barred flag to indicate whether or not the cell is barred. If the cell is barred, then the UE is not permitted to camp on that cell and the UE has to wait 300 seconds before rechecking the MIB to determine whether or not the cell remains barred. If a cell is barred, the intra-frequency reselection flag within the MIB indicates whether or not the UE is permitted to camp on another cell belonging to the same carrier frequency. SIB1 is known as the remaining minimum system information RMSI. It provides a list of PLMN identities and specifies a tracking area code for each PLMN. It also provides a set of parameters which define the cell selection criteria. 3GPP specifies the cell selection criteria, also known as S criteria, is given on the screen. QRX level measured is the SSRS-RP measured by the UE. In the case of cell selection, 3GPP documents not specify the rules for deriving a cell level measurement from a set of beam level measurement. Instead, this derivation is left to the UE implementation. Figure on the screen shows some example solutions for deriving the cell level measurement from a set of beam level measurements. The first example assumes that the cell level measurement is based upon only the strongest beam. In this case, cell selection is effectively completed using beam level measurements rather than cell level measurements. The second example assumes that the cell level measurement is derived from the X strongest beams, whereas the third example assumes that the cell level measurement is derived from all beams which exceed a specific threshold. QRX level minimum defines the minimum RS-RP threshold for the cell. It is broadcast by SIB1 and can be configured with a value between -140 and -44 dBm using a step size of 2 dBm. Its value defines the ideal mode coverage area of the cell. A high value will restrict the coverage area, whereas a low value may lead to failed connection setup attempts at cell edge. An initial value can be based upon the maximum allowed path loss calculated from a set of uplink and downlink budgets. Subsequent field trials can be used for optimization. QRX level minimum offset is included within the S criteria when a UE is completing a periodic search for a higher priority PLMN while camped on a visited PLMN. The value of QRX level minimum offset is always positive, so the cell selection criteria becomes more stringent. The objective of using this offset is to help reduce the potential for ping pong. P compensation. P compensation is used to adjust the value of QRX level minimum according to the UE transmit power capability. In a simple deployment scenario, P compensation is given by this formula, where PEMAX1 is the maximum allowed uplink transmit power within the cell broadcast within SIB1, and power class is the maximum transmit power capability of the UE. It is assumed that the value of QRX level minimum has been configured based upon a UE transmit power equal to PEMAX1. UE which have a transmit power capability less than PEMAX1 may not be able to establish a connection at cell edge. In that case, P compensation is used to make the S criteria more stringent to avoid those UE camping on the cell at locations where they cannot establish a connection. In a more complex deployment scenario, SIB1 can broadcast multiple maximum UE transmit powers. The primary maximum UE transmit power is PEMAX1, which is used for the simple deployment scenario and is included within the frequency info UL section of SIB1. Additional maximum UE transmit powers can be broadcast within an instance of NR NS PMAX list. Each additional maximum UE transmit power is linked to an additional spectrum emissions requirement. That is, the UE is permitted to use another maximum transmit power if it is able to achieve the specified spectrum emission requirement. The UE selects the first pair of values within the list which are supported and set PEMAX2 equal to the corresponding additional maximum UE transmit power. The UE then calculates P compensation by this formula given on the screen. This more complex deployment scenario can lead to a negative value of P compensation which increases a cell range. This can be elaborated as example shown on the screen here. Q offset temp is defined by the value of connection establishment failure offset within the connection establishment failure control section of SIB1. This temporary offset is applied if the UE experiences repetitive connection setup failures caused by T300 expiring. That is, the UE does not receive an RRC setup nor RRC reject message after sending an RRC setup request. The temporary offset is applied for a period of time T if T300 expires for n consecutive connection setup attempts where T is equal to connection establishment fail offset validity and n is equal to connection establishment fail count. The temporary offset makes the S criteria more stiff, so the UE is more likely to start searching for another cell. Q quality measured. Q quality measured is the SSRSRQ measured by the UE. Similar to QRX level measured, the UE is responsible for deriving the cell level measurement from the set of beam level measurements, assuming the UE detects multiple beams. Q quality minimum. Q quality minimum defines the minimum RSRQ threshold for the cell. It can be configured with a value between -43 and -12 decibel, using a step size of 1 decibel. A high value will restrict the coverage area, whereas a low value may lead to failure connection setup attempts. Q quality minimum is optional within SIB1, so it is not mandatory to use an RSRQ threshold during cell selection. The UE assumes a value of -infinity for Q quality minimum if it is excluded from SIB1, that is, ensuring that the UE always passes the sequel part of the S criteria. Q quality minimum offset is included within the S criteria when a UE is completing a periodic search for a higher priority PLMN while camped on a visited PLMN. The value of Q quality minimum offset is always positive, so the cell selection criteria become tough. The objective of using this offset is to help reduce the potential for ping pong.